All right, guys, what we're going to be doing in this lesson is continuing our work with logarithms and learning a couple of new rules, which are just things that we can do, with logarithms to kind of move them around and make them easier to work with. Okay, so these are called properties of logarithmic functions. As I go through these properties, I want you to remember that logarithms represent exponents. So logarithms do what exponents do. Like we have a product rule, a quotient rule, and a power rule in regards to exponents and what they can do. So we have corresponding rules with logarithms because they will follow suit. It's just going to look a little bit different, okay? So the product rule states that when you have a logarithm and you've got two things inside here that are multiplied together, it will follow the exponent product rule in that it will say, that the exponents add each other when two things are multiplying. So basically what you need to do is you need to remember that product rule means add the exponents. So product rule here means add the logarithms. Okay, here's what I mean. Let's say I have log base 4 of, 5x. 5 and x multiply together, right? So what I can do is I can use product rule, the logarithm product rule, and I can break this up and say that this is the same as log base 4 of 5 plus log base 4 of x. Okay, now right now it's probably not making a lot of sense as to why you would do this, but I can tell you that we're going to do this to help us solve equations. So this is like the natural next step, okay? So that's product rule, times equals plus. That's what you need to remember. Quotient rule, the rule with exponents is that if they're written in a fraction or a quotient, you can subtract the exponents. So the logarithm rule is also going to be that. If you have two things being divided in a logarithm, you can also write it as subtracting those two things. So let me get you an example. Let's go log base 2 of, y divided by 10. Okay, so using the logarithmic quotient rule, I can say that quotients equal subtraction. Therefore, I could write it as log base 2 of y minus log base 2 of 10. By the way, it does have to be the numerator goes first and the denominator goes second with this rule. Then there's power rule, and power rule in exponent world, power rule means that if you have something raised to a power, you multiply the powers. So here, it's going to look a little different. It is still going to be multiplication. You're just going to take the power and multiply it in the front of your logarithm. And that is the same thing as exponent power rule, because remember, a logarithm really equals an exponent. So it's kind of the same thing as saying multiply the exponents. So let's go, actually, maybe I'll show you with ln. Sometimes we forget ln is also a logarithm. So let me just show you with ln. Remember, ln is log base e. Let's say that I have, x to the 8th power here. So if I want to invoke logarithmic power rule, that would just be me taking the 8 to the front and writing ln of x. So 8 ln of x is the same as ln x to the 8th power. They're equivalent expressions, okay? The same thing goes for going the other direction as well. So if I have a subtraction like this with two separate logarithms, I can turn it back into a quotient, or I can turn it back into a product, or back into a power rule situation. Just kind of depends on what we need at that time. So a large portion of what you're doing in this homework assignment is you are expanding or condensing using the properties. So you're going through and you're saying, what do I see? I see product 2 times, and I see a power rule. So I'm going to show how you can expand all this out using the rules we just saw. So I'm going to do this in 2 steps. I'm going to start with a product rule. So product rule is plus, which means I can break up each thing that's being multiplied with a plus sign in between each thing. Okay, so that's what this would give me here. I could do one additional step with this third term because it has a power. So I could use power rule that allows me to multiply the power by the logarithm. So we're going to do nothing with the first two terms. Keep them the same. And then this last term I'll write as 4 times log y. So this is what expanding a logarithm would look like, taking it from one term to 3 different terms in this specific case. The next example is what a challenge problem could look like. And the reason why it's a challenge problem is because there's a radical. You need to remember that radicals are the same, square roots specifically, are the same as something to the 1/2 power. So this problem is really a power rule because of this guy here, and also a quotient. Okay, so we're gonna let's do the quotient part first. I think it's easier to do that part first. So we're gonna say we can do quotient rule by taking the numerator and putting it in its own little group here, minus the denominator. Then from there, I can take this power, sorry if you hear my kids, I can take the power and put that in the front and make it power rule. So I could say this 1/2 could be multiplying the logarithm, natural logarithm in this case, minus ln x. Okay. Condense the following logarithmic expression using the properties. So here what you would be doing is going in reverse. So condense means squish it back down and make it one thing. So like we've been working over here with making it longer and expanding it, we're going to go backwards. So instead of saying, oh, I see times and that means plus, I'm going to say, oh, I see plus and that means times. I'm going to go backwards. So I see right off the bat, I see a minus, and I also see this 2 in front, which that means that this 2 would have been an exponent. So like in the last 2 examples, we were moving the exponents to the front and multiplying. Now we're going to move those numbers that are multiplying back as an exponent. So let me start with that, and we'll write it as ln of x, y, to the 5th power like this. And then we're going to address this minus sign. So minus means quotient. So when you do this condensing step, by the way, you're putting everything back into a single logarithm. Okay? Kind of messed up. Let me try that again. You're putting everything back into a single logarithm. Okay, whatever comes first goes in the numerator, and whatever is second goes in the denominator. And you know what? This time, we could even clean this up a bit more. This answer's fine. We could clean it up a bit more, though, because we have, on the bottom, we really have x to the 5th, y to the 5th, don't we? And do you see how the x's can cancel and simplify? So this is interesting because really you just have 1 over y to the 5th on the inside. So let's condense it all the way down like that. Okay, a couple more. Same thing again. You're just looking for like clues. So like a minus means quotient. They're both logarithms. Do you remember what the base is if there's no base written? This is actually base 10, remember? Which we don't have to write it. It's just called the common log. But minus means quotient. So whatever's first goes on top and whatever's second goes on bottom. So that one was pretty short and sweet. This one down here, I see a couple numbers in the front, so we probably should move those back. Remember, those were your power rules. Numbers in front that have multiplied were originally powers. So we'll start there. So we have x to the 3rd y. There's a 3 here now. And then ln of y z squared. We'll now have a 2 over here. And then there's one more thing we can do, right? Because what's plus mean? Plus means product rule. Let me use a bracket because this is going to get a little messy. So I can do one more step. And I can turn this back into a product by doing product rule in reverse. So that takes me to here. And then with all this stuff inside, we can simplify it just using like normal exponent rules, can't we? So let's try to do that real quick. So let's make this x to the ninth, y to the third, and then y squared, z to the fourth. And then one more step should do it. So this would be x to the ninth, y to the fifth, because add the exponents, z to the fourth. So that would be completely simplified as far as you could go. Okay, change of base. I think we talked about change of base last time, but let's go over it. Maybe we didn't, but let's go over it real quick. It's a really simple concept. So the idea is if you have a regular scientific calculator, not a fancy one, and you want to compute a logarithm, you can only do so if it's a log base 10 or a ln, because those are the only buttons on the calculator. So what you can do is you can do something called change of base formula, which is basically going to allow you, let's get this one out of here, that's not helpful, which is going to allow you to take something that has a base, I don't know, let's say log base 5 of 9. I cannot type this in a calculator, but if I use change of base formula, I can change it to log of 9 over log of 5 and type that into the calculator. Or I can use ln. It actually will give you the same answer either way. So you can choose whether you want to use log or ln, but this is just going to allow you to take something that was not computable in a calculator to something that is computable in a calculator. Okay, that's all this is. For example, it says evaluate the logarithms by changing the base. So if I was asking you to do this on a homework assignment or quiz or something, I would want to see your work showing how you used change of base formula, which by the way is just this number will go on top and then the base number goes on bottom. Okay, that's all. So I would write it, I chose log this time instead of ln, but log of 13 divided by log of 3, type it in the calculator and you get 2.335. Okay, what about log base 6 of 10? I used ln this time to show you something different. So it would be ln of 10, always this number first, divided by ln of the base, which is 6, and that's 1.285. Again, you would get the same answer if you use ln or log. Okay, works with fractions and weird bases as well. So log base or log of 2 divided by log of 1/2 will give you an answer of -1. Anybody know why this one's not a decimal? It's not a decimal because you could have computed it without using a calculator. Log base 1/2 of 2. That means 1/2 to what power equals 2. See how these are flipped? A negative exponent, like -1, would make that a reciprocal. So that's why your answer is not a decimal that time. Okay, that's pretty much it. This warm-up is something that we will continue with in our next lesson. So hopefully you have enough information to help you complete the homework assignment. If not, please reach out and I will help you as much as I can.